Velocity is a ghost. It leaves no footprint, makes no sound, and unless you are subjected to the violent force of acceleration, it is fundamentally impossible to feel. Right now, you perceive yourself to be at rest. The foundation of your house is static. The air in your room is quiet. But this sensation of absolute stillness is the greatest physiological lie your nervous system has ever told you. Strip away the atmosphere. Strip away the mundane friction of daily life and observe the cold, uncompromising vectors of our trajectory. The Earth is spinning at roughly 1,000 miles per hour. It is simultaneously hurtling around the Sun at 67,000 miles per hour, and the Sun itself is dragging our entire planetary system through the interstellar medium, orbiting the supermassive black hole at the center of the Milky Way at an excess of 500,000 miles per hour. For a long time, astrophysicists believed this was the final tally of our cosmic accounting. We had mapped the intricate clockwork of our local existence. We understood our orbit. We knew our exact place in the void. Then, we decided to measure our absolute motion against the oldest light in existence, the cosmic microwave background. This is the primordial radiation left over from the Big Bang, an ancient thermal grid that permeates the entirety of space. It is the ultimate cosmic reference point. And when we calibrated our instruments against this absolute background, the mathematics shattered. When all known local velocities are subtracted, when the spin of the planet, the orbit of the star, and the immense rotation of the galaxy are completely zeroed out, a massive, terrifying residual vector remains, a persistent, undeniable direction of travel that defies the established models of our local universe. We are not just spinning, we are falling. The entire Milky Way galaxy, containing hundreds of billions of stars and trillions of planets, is not drifting randomly, it is being pulled, and we are not alone. The Andromeda Galaxy, our massive neighbor, along with tens of thousands of other galaxies in our local supercluster, are all moving together in a unified cosmic river. It is a relentless, synchronized migration across the dark, plunging through deep space at over 1.3 million miles per hour. We are being dragged toward a singular set of coordinates. Something of incomprehensible scale is reeling us in. An anomaly so immense that its gravitational authority dictates the trajectory of our entire region of the universe. Yet, when astrophysicists pointed our most advanced observatories toward the exact origin of this pull, they hit a blind spot. If you seek the truth hidden in the dark, subscribe and join us on this journey. To understand the sheer magnitude of this vector, we must first dismantle the architecture of human perception. You are biologically engineered to be deceived. Millions of years of terrestrial evolution have hardwired the human brain to process motion in purely local terms. A predator moving through the tall grass, a rock falling from a cliff. Our sensory apparatus is optimized for a flat, stationary hunting ground. To our inner ear and to the primitive firmware of our neurology, the ground beneath our feet is the absolute center of reality. But physics cares nothing for human intuition. In the early 17th century, Galileo Galilei proposed a thought experiment that would shatter the medieval understanding of motion. He asked us to imagine being locked inside the windowless cabin of a large ship. If the ship is moving across a perfectly calm sea at a constant velocity without any acceleration or deceleration, the passengers inside would have absolutely no physical way to know they were moving. A drop of water falling from the ceiling would still hit the floor perfectly straight. A thrown object would behave exactly as it would on solid ground. Without an external reference point, without a window to observe the shore, slipping away velocity is fundamentally invisible. This principle of Galilean relativity established a cold, indifferent truth. There is no such thing as absolute rest. Motion is only meaningful when compared to something else. For centuries, this was a perfectly adequate framework for navigating our solar system. We measured the Earth against the Sun. We measured the Sun against the surrounding stellar neighborhood. But as our optical engineering became more sophisticated, the parameters of our ignorance began to expand exponentially. In the 1920s, high atop the freezing, isolated peaks of the San Gabriel Mountains in California, astronomer Edwin Hubble sat inside the dome of the Mount Wilson Observatory. He was operating the 100-inch Hooker telescope, an absolute leviathan of glass and steel. Night after night, Hubble captured photons that had been traveling through the void for millions of years, focusing them onto delicate photographic plates. He was observing a specific type of star known as a Kiffid variable, a pulsating cosmic beacon that allows astronomers to calculate immense distances. Hubble was not merely looking at the stars, he was dissecting their light, and in that dissection, he found a terrifying signature. When a source of light moves toward you, its light waves are compressed, shifting toward the blue end of the electromagnetic spectrum. When it moves away, the waves are stretched, shifting toward the red end. It is the exact visual equivalent of an ambulance siren dropping in pitch as it speeds past you in the dark. Hubble noticed that almost every single galaxy outside our immediate local group was redshifted. Their light was stretched. They were all moving away from us. Furthermore, the further away a galaxy was, the faster it was Miocene. The universe was not a static, eternal vault. It was exploding outward. Space itself was expanding, stretching like a rubber sheet, carrying the galaxies with it. This revelation introduced a profound mathematical dilemma. If everything is moving away from everything else, where is the center? Where is the baseline? Imagine standing in an infinitely large, dark warehouse filled with thousands of floating digital servers, all slowly drifting apart. If you wake up on one of these servers, how do you determine your true speed? You can measure how fast you are moving relative to the server next to you, but because the entire grid is in motion, determining your absolute velocity through the warehouse seems mathematically impossible. Albert Einstein's theory of general relativity compounded this existential dread. Relativity states unequivocally that the laws of physics are the same for all non-accelerating observers. It insists that the universe has no preferred frame of reference. There is no master grid. There is no cosmic anchor. We are entirely adrift in a localized bubble of perception, forever exiled from knowing our true velocity across the grand canvas of reality, or so we thought. The universe, in its cold and mathematical elegance, actually possesses a memory. It left behind a fossil. In 1964, two radio astronomers, Arno Penzias and Robert Wilson, were working at the Bell Labs facility in Holmdel, New Jersey. They were using a massive, ultra-sensitive horn antenna, originally built to detect signals bouncing off early satellite reflectors. But every time they pointed their antenna to the sky, they encountered a problem: a persistent, low-frequency hiss, a static noise that bled into their instruments, refusing to disappear no matter where they aimed the machine, regardless of the time of day or the season of the year. They cleaned the antenna, evicted nesting pigeons, and recalibrated their electronics, yet the static remained. It was not a malfunction. It was the echo of creation. Penzias and Wilson had stumbled upon the cosmic microwave background. To grasp what this is, you must rewind the clock 13.8 billion years. In the immediate aftermath of the Big Bang, the universe was not the cold, dark vacuum we know today. It was a suffocatingly dense, hyperheated fog of subatomic particles and blinding radiation. It was so dense that light itself could not travel. Photons were constantly trapped in a violent pinball game, smashing into free electrons. But as the universe expanded, it cooled. Approximately 380,000 years after the initial expansion, the temperature dropped just enough for electrons to bind to protons, forming the first stable hydrogen atoms. In a single, sweeping cosmic instant, the fog cleared. The universe became transparent. The trapped light was finally unleashed, blasting outward in every conceivable direction. That light has been traveling through the expanding cosmos ever since. Over billions of years, the relentless stretching of space has pulled those ancient, blindingly hot light waves apart, elongating them until they cooled down into the microwave spectrum. Today, this radiation permeates every cubic millimeter of the universe. It sits at a freezing 2.7 degrees above absolute zero. It is the oldest light in existence, forming a perfect spherical shell around us at the edge of the observable universe. Astrophysicists realized immediately that this ancient radiation offered something Einstein said shouldn't exist: a universal reference frame. The cosmic microwave background is the ultimate backdrop. It is the canvas upon which the entire history of the universe is painted. Because it is everywhere, and because it is relatively uniform, it can be used as a static background against which to measure the motion of anything inside it. If the Earth, the Sun, and the Milky Way were perfectly still relative to the universe's overall expansion, the temperature of this background radiation should appear perfectly identical in every direction we look, but it does not. When we launched highly sensitive orbital observatories first, the COBE satellite, then WMAP, and finally the Planck spacecraft, to map this ancient light with microscopic precision, a glaring anomaly emerged in the data. The temperature of the background radiation was not uniform. The instruments detected a distinct dipole pattern. When we look in one specific direction of the sky, toward the constellation of Leo, the cosmic microwave background is slightly warmer. It is blue shifted by a few thousandths of a degree. When we look in the exact opposite direction, toward the constellation of Aquarius, the background is slightly colder. This temperature differential is astonishingly small, barely a fraction of a Kelvin, but the mathematics behind it are brutal and conclusive. It is the Doppler effect acting on the oldest light in the universe. We are hitting the photons in front of us slightly harder and running away from the photons behind us. This discovery annihilated the illusion of our cosmic drift. It meant that we are not merely floating along with the general expansion of space. We are actively moving through it. We have what astrophysicists call a peculiar velocity, while the fabric of the universe stretches out beneath a phenomenon known as the Hubble flow-hour. Local region of space has established its own rogue trajectory. Imagine a vast, slow-moving river representing the expansion of the universe. Now imagine a massive fleet of ships caught in a powerful, localized whirlpool that is dragging them across the current. When the engineers crunched the numbers from the satellite data, factoring out the rotation of the Earth, the orbit of the Sun, and the spin of the Milky Way, the final remaining vector was staggering. Our entire galaxy is being dragged in a singular direction at an estimated speed of 600 kilometers per second. that is 1.3 million miles per hour. At this speed, you could travel from the Earth to the Moon in 10 minutes. And we are not making this journey alone. The gravitational drag is so immense that it is pulling the entire local group of galaxies with it. The Andromeda Galaxy, the Triangulum Galaxy, and dozens of dwarf galaxies are all locked into this exact same vector. But a velocity of this magnitude requires a staggering amount of force. To accelerate a mass as unfathomably huge as the Milky Way, hundreds of billions of stellar masses, enveloped in a halo of dark matter to over 1 million miles per hour, requires a gravitational engine of apocalyptic proportions. According to the laws of Newtonian mechanics and general relativity, mass attracts mass. If we are falling, something must be pulling us. Something with a gravitational well so deep, so dense, and so structurally massive that it commands the architecture of tens of thousands of light years. Naturally, astronomers pointed their telescopes toward the precise coordinates of this cosmic pull, expecting to find an unimaginably huge supercluster of galaxies. A concentration of matter so dense it would easily explain our terrifying speed. They calibrated the lenses, filtered the cosmic noise, and focused their instruments on the exact patch of sky dictating our fate. When the astronomers calibrated their lenses and focused their instruments on the exact coordinates of this apocalyptic pull, expecting to map the greatest concentration of mass in the known universe, they were met with a cosmic joke. They found a wall, not a metaphorical barrier, but a physical, insurmountable obstruction woven into the very fabric of our night sky. If you look up on a clear, perfectly dark night, away from the light pollution of modern cities, you will see a pale, luminous band of light stretching across the heavens. It looks like spilled milk, a ghostly arch that ancient civilizations worshipped as a river of spirits. This is the Milky Way. It is the disk of our own galaxy, seen from the inside. It is beautiful to the naked eye, but to an astrophysicist searching for the true nature of our cosmic trajectory, it is a nightmare. Our solar system is located in the Orion Spur, a minor appendage situated about 27,000 light-years from the galactic center. Because our galaxy is shaped like a flat, spinning record, when we look up or down out of the galactic plane, our view into deep space is relatively clear. We can see the distant universe, the ancient quasars, the expanding void, but when we look directly along the plane of the disk, our line of sight is entirely blocked by the dense, chaotic machinery of our own galaxy. This region of the sky is mathematically designated by astronomers as the Zone of Avoidance. It is a fitting, almost ominous name. It covers roughly 20% of the entire celestial sphere. For decades, it was a region completely omitted from cosmic maps, a dark terra incognita where the light from distant galaxies simply could not penetrate. To understand why, you must understand the violent, dirty nature of interstellar space. The space between the stars is not empty. It is choked with colossal clouds of interstellar dust and molecular gas. These grains of cosmic dust, microscopic particles of carbon, silicates, and frozen ice act as an absolute barrier to visible light. When photons from a distant galaxy travel millions of light years toward Earth, they can survive the empty, freezing deserts of intergalactic space. But the moment they hit the perimeter of the Milky Way, they plunge into these dark nebulae. The shorter wavelengths of visible light are scattered, absorbed, and utterly destroyed by the dust. It is exactly like trying to use your car's high beams in a dense, blinding fog. The light simply bounces back at you, illuminating the fog itself while hiding the massive truck hurtling toward you from the darkness, and the exact coordinates of the gravitational anomaly pulling us. The precise mathematical origin of our 1.3 million mile power freefall lie directly behind the thickest, most impenetrable part of the galactic center, spanning the constellations of Sagittarius, Centaurus, and Norma. We are hurtling toward a titan, and our own galaxy has blindfolded us. For a long time, the zone of avoidance was accepted as an immovable boundary of human knowledge. But science is propelled by an obsessive refusal to accept the dark. In the mid-1980s, a team of 7 brilliant astronomers, who would later become known in the astrophysics community as the Seven Samurai, decided to map the impossible. They did not try to pierce the blind spot directly. Instead, they mapped the currents of the ocean to find the location of the submerged drain. Their project was a masterpiece of cold, grueling, observational astronomy. The team, David Burstein, Roger Davies, Alan Dressler, Sandra Faber, Donald Lynden Bell, Roberto Turlovich, and Gary Wegner, set out to measure the precise motions of 400 massive elliptical galaxies scattered across the sky. Elliptical galaxies are ancient, tightly bound spheres of older stars. Unlike spiral galaxies, they lack the chaotic regions of active star formation, making their intrinsic brightness much easier to calculate. To map the flow of the universe, the Seven Samurai had to execute a mathematically brutal task. For every single galaxy, they had to measure 2 distinct, conflicting numbers. First, they needed the galaxy's redshift, which tells us how fast the universe's expansion is pushing it away. Second, they needed the galaxy's actual distance from Earth, independent of the expansion. By comparing the expected velocity caused by the expansion of space against the actual observed velocity of the galaxy, they could isolate its peculiar velocity, its true local motion through space. It is like watching a leaf floating down a moving river. If you know exactly how fast the river is flowing, and you measure the absolute speed of the leaf, you can calculate the unseen wind that is blowing the leaf across the water. They spent years collecting data from telescopes scattered across the globe, processing the faint spectra of hundreds of galaxies. When they finally synthesized the data and mapped the velocity flow field of our local universe, the geometry that emerged was terrifying. The galaxies were not moving randomly. The peculiar velocities were not the result of local gravitational squabbles between neighboring star clusters. Almost everything they measured, an entire hemisphere of the cosmos, spanning hundreds of millions of light-years, was caught in a massive, coordinated drift. The Milky Way, the Andromeda Galaxy, the Virgo Cluster, containing thousands of galaxies, the Shapley Supercluster, millions of galaxies, representing a significant fraction of the observable universe, were all cascading in the exact same direction, flowing like tributaries into a single, unseen ocean. Alan Dressler, analyzing the sheer scale of the convergence, gave the phantom anomaly a name. He called it the Great Attractor. The naming of the Great Attractor was a pivotal moment in modern cosmology. It crystallized a profound existential terror into a scientific fact. We were no longer simply drifting, we were being summoned. But the mathematics required to justify the existence of the Great Attractor were staggering, pushing the limits of the known laws of physics. Gravity is, paradoxically, the weakest of the 4 fundamental forces of nature. A simple refrigerator magnet can defeat the gravitational pull of the entire planet Earth. For gravity to exert influence over hundreds of millions of light-years, dragging entire superclusters of galaxies at tremendous speeds, the mass involved must be almost incomprehensible. The equations of general relativity demanded that the Great Attractor possess a mass equivalent to tens of thousands of Milky Way galaxies. We are talking about tens of quadrillions of solar masses concentrated in a localized region of space, a structure so dense and so overwhelmingly massive that it acts as the gravitational anchor for our entire corner of the universe. And yet, it remained invisible, cloaked behind the dusty, glowing disk of our own home. To see the Great Attractor, astrophysicists realized they had to abandon the visible spectrum entirely. They had to stop looking with human eyes and start looking through the lens of pure radiation. The microscopic dust grains that block visible light are highly effective at scattering short wavelengths like blue and green light. But as the wavelengths of light become longer and longer, they gain the ability to simply bypass the dust. It is a fundamental property of wave mechanics. Imagine a massive ocean swell rolling toward the coast. It will easily pass around small wooden posts in the water, whereas tiny surface ripples will be disrupted by them. The strategy shifted from optical telescopes to the heavy artillery of astrophysics, infrared satellites, X-ray observatories, and massive radio dishes. In the late 1990s and early 2000s, an ambitious project called the High Parkes All-Sky Survey was launched in Australia. Astronomers utilized the Parkes Radio Telescope, colossal 64-meter parabolic dish pointing toward the southern sky. Instead of looking for starlight, the Parkes dish was tuned to detect the 21-centimeter emission line. This is a highly specific radio frequency emitted by neutral hydrogen gas, the most abundant element in the universe. Because radio waves are incredibly long, they slice through the dust of the Milky Way as if it does not exist. For the first time, humanity peered directly into the heart of the Zone of Avoidance. The blind spot was lifted. The raw data poured into the server banks, painting a ghostly, monochromatic map of the structures hidden behind our galaxy. What they found in the dark was an archipelago of violence, lurking exactly where the mathematics predicted, roughly 150 million light-years away. Nestled in the constellation of Norma, they found a monster. It was catalogued as Able 3627, now known as the Norma Cluster. Through the X-ray vision of the Rosat satellite, astronomers observed that this cluster was not just a quiet gathering of stars. It was a chaotic, boiling war zone of cosmic engineering. The Norma Cluster is massive. It is incredibly dense, filled with giant elliptical galaxies and swathed in a halo of superheated gas that emits blistering amounts of X-ray radiation. Entire galaxies are being ripped apart as they plunge into its gravitational well, leaving trailing wakes of stripped gas behind them like blood in the water. It is exactly the kind of massive, dominant structure one would expect to be the engine of the Great Attractor. The scientific community breathed a collective sigh of relief. The monster had been found. The ghost had a body. The agonizing mystery of our cosmic plunge seemed, for a brief moment, solved. The Milky Way was falling toward the Norma Cluster. But science is rarely that merciful. When astrophysicists painstakingly calculated the total mass of the Norma Cluster, including the dark matter holding it together, the numbers collided with reality like a freight train. The mass was huge. It was equivalent to roughly 1,000 trillion suns, but it was not enough. In fact, it was not even close. The cold, unforgiving equations of orbital mechanics dictated that to pull the Milky Way, the Virgo Supercluster, and the Hydra Centaurus Supercluster at the speeds we were measuring, the Great Attractor needed to be 10 times more massive than the Norma cluster. The massive structure we found hiding behind the dust was nothing more than a foothill. It was a single, dense neighborhood in a much larger, invisible city. The realization sent a shockwave through the cosmological community. The Norma cluster was indeed part of the Great Attractor, but it was merely the tip of the iceberg. The gravitational anomaly was not a single object, nor a single cluster. It was a region of space so vast that it defied our localized definitions of structure. The phantom mass was still out there, its true center of gravity, located even deeper in the void, hidden further away behind the dense, dusty equator of our galaxy. The vector of our trajectory remained unbroken. The speed remained constant. The Milky Way was still plunging into the dark, pulled by a leviathan that had survived our best attempts to unmask it. The scale of the mystery had not been resolved. It had violently expanded. We were no longer looking for a missing galaxy or a hidden cluster. We were looking for a flaw in the architecture of the universe itself. When the mass of the Norma cluster proved to be a mere fraction of what the equations demanded, astrophysics found itself facing a catastrophic auditing problem. The ledgers of reality did not balance. The gravitational gravity well we had finally managed to map behind the zone of avoidance was too shallow to account for the relentless, synchronized migration of our local universe. It was equivalent to observing a massive runaway freight train and discovering that its engine is a simple lawnmower motor. The mechanical cause did not match the kinetic reality. The Great Attractor was not a singular, discrete object that we could simply isolate and weigh. The very concept of looking for a localized clump of mass was a flaw in our methodology, a lingering bias of planetary thinking. We were looking for a mountain, but the universe operates on fluid dynamics. We were not falling toward a mountain, we were caught in a watershed. To comprehend the true architecture of our confinement, a fundamental shift in observation was required. In 2014, a team of astronomers, led by R. Brent Tully at the University of Hawaii and Helene Courtois at the University of Lyon, decided to abandon the traditional method of mapping the cosmos. Until that point, cosmic cartography had relied heavily on mapping the static positions of galaxies, plotting them like cities on a two-dimensional map. But Tully and Courtois understood that in a universe governed by gravity, position is secondary. The only metric that reveals true structure is motion. They compiled the precise, peculiar velocities of 8,000 galaxies. Instead of looking at where these galaxies were, they mapped the exact vectors of where they were going. To process this immense data set, they applied an advanced mathematical algorithm known as the Wiener filter, originally developed in the 1940s to filter out noise from radar and communication signals. The Wiener filter allowed the team to reconstruct the continuous three-dimensional flow of gravity from a fragmented, noisy set of discrete data points. When the supercomputers rendered the final mathematical model, the resulting visualization was breathtaking and terrifying. The universe was not a collection of isolated clusters floating in a void. It was a vast, interconnected filamentary structure, a cosmic web of dark matter and gas that looked uncomfortably like the neural pathways of a colossal biological brain. And within this web, galaxies were flowing like beads of water along invisible threads. By tracing the velocity flow fields, the researchers identified a distinct topological boundary in space. Imagine a vast mountain range on Earth. When rain falls on the peaks, the water separates along a continental divide. Water on one side flows into one ocean. Water on the other side flows into an entirely different ocean. The exact same principle dictates the movement of galaxies. Tully and his team discovered that the Milky Way, the Andromeda Galaxy, the Virgo Cluster, and the Great Attractor itself are all contained within a single, unimaginably immense basin of gravitational attraction. They named this structure Laniakea, a Hawaiian word meaning immense heaven. Laniakea is a supercluster of galaxies that stretches across 520 million light-years of empty space. It contains over 100,000 galaxies, encompassing the mass of 100 quadrillion suns. In this newly defined cosmic geography, the Great Attractor is not an anomaly. It is simply the gravitational focal point of our local basin. It is the bottom of the valley. Every galaxy within Laniakea is flowing downward toward this central region, dragged along the contours of a dark matter valley that dictates the ultimate fate of our local cosmic neighborhood. For a brief, fleeting moment, it seemed as though the grand equation had finally been solved. We had mapped the valley. We understood the flow. The ghost had been contained within the defined borders of Laniakea, but the mathematical piece was an illusion. The relief was premature, shattered by the cold, unyielding data of the cosmic microwave background. When cosmologists cross-referenced the total mass and gravitational pull of Laniakea with the absolute velocity of our galaxy derived from the CMB dipole, that persistent 1.3 million mile-power freefaller, new, horrifying deficit emerged. The entire Laniakea supercluster, with all its 100,000 galaxies and its massive dark matter scaffolding, is still not enough to explain our absolute motion. Laniakea can account for our local flow, but it cannot explain why the entire basin itself is moving. We are not just a droplet of water sliding down into a valley. The entire valley is being dragged across the tectonic plates of the universe. Astrophysicists were forced to cast their gaze even further into the dark, beyond the borders of our supercluster, looking deeper along the vector of our trajectory, over 650 million light-years away, lying far behind the Great Attractor and partially obscured by the same galactic dust. They found the Shapley Supercluster. If Laniakea is a continent, the Shapley concentration is a planetary heavyweight. It is the most massive concentration of galaxies in the observable universe, a gravitational leviathan packing the mass of 10,000 Milky Ways into a relatively compact volume of space. The Shapley Supercluster exerts a gravitational pull so dominant that it is literally reeling in Laniakea. We are caught in a nested hierarchy of doom. The Milky Way is falling toward the Great Attractor. The Great Attractor is falling toward the center of Laniakea, and the entirety of Laniakea is being hauled through the void toward the Shapley concentration. To compound this celestial nightmare, scientists realized that gravity does not only pull. In the grand, relativistic architecture of the cosmos, the absence of mass also pushes. In 2017, cosmologist Yehuda Hoffman introduced the concept of the dipole repeller. When mapping the cosmic flows, his team noticed that while we are accelerating toward Shapley, we are simultaneously fleeing from a massive, desolate region of space directly behind us. This region is a cosmic void, a sprawling, empty sector of the universe, largely devoid of galaxies and dark matter. In a universe where mass is unevenly distributed, a completely empty void exerts a relative negative pressure. It acts as a gravitational repeller. We are not just being pulled by the immense mass ahead of us. We are actively being expelled by the suffocating emptiness behind us. The universe is squeezing us out of the void and hurling us toward the wall of mass. With Shapley pulling, and the dipole repeller pushing, the scientific community believed that the ultimate parameters of our 1.3 million mile power journey were finally accounted for. The ledgers, stretched to their absolute limits, seemed to balance. The standard model of cosmology, known as the Lambda CDM model, which dictates that the universe is homogeneous and isotropic on its largest scales, had survived. And then, the dark flow ripped the consensus to shreds. The standard model of cosmology rests on a fundamental pillar known as the cosmological principle. This principle states that if you look at the universe on a large enough scales, zooming out past the galaxies, past the clusters, and past the superclusters, the cosmos should look identical in every direction. The matter should be evenly distributed, like a fine mist. Because of this even distribution, the gravitational pulls from different directions should cancel each other out. On the grandest scale imaginable, there should be no overarching directionality. There should be no universal rivers. The cosmic flow should stop. But in 2008, an astrophysicist named Alexander Koshlinsky and his team at NASA's Goddard Space Flight Center found something in the dark that fundamentally violates this principle. Koshlinsky was not looking at the movement of individual galaxies. He was looking at the movement of entire galaxy clusters, massive, sprawling structures containing hundreds of galaxies bound together by superheated gas. To measure their motion, his team utilized one of the most obscure and complex phenomena in astrophysics, the kinematic Sunyaev-Zeldovich effect. The mechanics of this effect are brilliantly intricate. When the ancient, freezing photons of the cosmic microwave background travel across the universe, they occasionally pass through the incredibly hot, ionized gas that permeates a galaxy cluster. When these low-energy photons collide with the hyperactive high-energy electrons in the gas, they steal a tiny fraction of energy. This interaction slightly boosts the frequency of the photons, leaving a microscopic temperature shadow on the cosmic microwave background. But if the entire galaxy cluster is moving relative to the expanding universe, it alters this shadow. The motion of the cluster induces a Doppler shift in the scattered photons, creating a secondary, infinitely faint temperature distortion. It is a signature so incredibly weak that extracting it from the raw cosmic noise requires monumental computational power. It is the astronomical equivalent of trying to hear a specific snowflake hitting the ground during a raging blizzard. Koshlinsky and his team spent years analyzing data from the WMAP satellite, hunting for this kinematic Sunyaev-Zeldovich effect in over 700 galaxy clusters spread across billions of light years. They were attempting to measure the bulk flow of the universe on a scale that had never been attempted before. What they discovered sent a chill through the astrophysics community. The clusters were not floating randomly. They were not governed by local superclusters like Shapley. Across a massive swath of the observable universe, these hundreds of galaxy clusters, separated by billions of light years, were all moving in the exact same direction. They were migrating toward a specific patch of sky situated between the constellations of Centaurus and Vela, and they were moving at an astonishing speed of roughly 1,000 kilometers per second, over 2 million miles per hour. Koshlinsky named this relentless, unified migration the dark flow. The existence of the dark flow is a cosmological paradox of the highest order. The structures, Koshlinsky observed, are moving far too fast, and their coordinated movement spans a distance far too wide to be explained by any known mass within the observable universe. There is absolutely nothing in the cosmic maps, no supercluster, no concentration of dark matter, no great attractor, massive enough to synchronize the movement of matter on a scale of 3 billion light-years. According to the infallible mathematics of the Standard Model, the dark flow should not exist. It is a violation of the isotropic universe. It is a rogue current in an ocean that is mathematically required to be still. The implications of this discovery are profoundly terrifying because they force us to confront the absolute limits of human perception. We live within a sphere of reality known as the observable universe. The radius of this sphere is dictated by the speed of light and the age of the cosmos. Because the universe is only 13.8 billion years old, we can only see objects whose light has had enough time to reach us. Due to the expansion of space, this observable boundary extends in all directions for about 46 billion light-years. This boundary is the cosmological horizon. It is the absolute edge of our flashlight beam in the dark forest of reality. Whatever lies beyond that boundary is fundamentally invisible to us. Its light has not reached us, and because the universe is expanding faster than the speed of light, it never will. But gravity does not need light to transmit its influence. Gravity is the geometry of space itself. The prevailing and deeply unsettling theory surrounding the dark flow is that the massive structures pulling on our universe are not hidden behind the dust of the Milky Way. They are hidden behind the veil of time and physics. They are located outside the observable universe. During the first trillionth of a second after the Big Bang, the universe underwent a violent, incomprehensible phase of exponential expansion known as cosmic inflation. Space stretched faster than light, permanently pushing massive portions of the cosmos beyond our cosmological horizon. If this theory holds true, then just before inflation tore the universe apart, the matter that now makes up our observable reality was gravitationally entangled with matter that was suddenly thrust entirely out of our view. The dark flow is the phantom tug of that lost architecture. The clusters are being dragged by the gravitational ghosts of immense, unseeable superstructures that lie far beyond the edge of the observable universe. We are being pulled by a mass that we can never observe, toward a destination we can never reach, dictated by the presence of a universe that is vastly larger, stranger, and more terrifyingly complex than our localized physics can comprehend. The realization that our entire existence, the Milky Way, the Shapley Supercluster, might merely be a minor tributary feeding into a much larger, unknowable ocean, creates a fracture in our understanding of reality. We are forced to consider that the mathematics we have proudly developed over centuries of stargazing are fundamentally incomplete. If the dark flow is a permanent, physical feature of our cosmos, it effectively assassinates the cosmological principle. For decades, the foundational bedrock of modern astrophysics has been the assumption of isotropy. We believed that the universe, on its grandest scales, is a perfectly balanced equation. No matter where you stand, no matter what direction you face, the distribution of matter and energy should average out to a uniform, homogeneous mist. It is the comforting assumption that we live in a predictable, stable environment. But the dark flow reveals a terrifying asymmetry. The universe is not a balanced snow globe. It is lopsided. It possesses a tilt. We are like sailors who have mapped every inch of a seemingly calm sea, only to suddenly realize the entire ocean is steadily pouring over an imperceptible edge. To understand the true terror of this consequence, you must understand the mechanical violence of the universe's birth. Cosmology dictates that we are not simply looking at a distant region of space. We are observing a traumatic scar from the first fraction of a second of existence. The mechanism responsible for this phantom pull is rooted in a theory called cosmic inflation, proposed by theoretical physicist Alan Guth in the early 1980s. Inflation theory argues that roughly 10 to the power of minus 36 seconds after the Big Bang, the infant universe underwent a cataclysmic, exponential expansion in a window of time so brief it defies human comprehension. The fabric of space stretched by a factor of at least 10 to the power of 26. Space itself expanded at a velocity infinitely faster than the speed of light. This violently tore the primordial architecture of reality apart. Imagine a dense, microscopic knot of quantum fluctuations, tightly bound and gravitationally communicating with one another. When inflation triggered, this knot was obliterated. Pieces of our immediate cosmic neighborhood matter and energy that were intimately entangled with the particles that would eventually become you, me, and the Milky Way were hurled across distances so vast they shattered the boundaries of our observable horizon. Those exiled pieces of the universe did not simply vanish. Outside the 46 billion light-year radius of our observable bubble, they condensed. Over 13 billion years, they grew into monstrous, unseeable titans, colossal structures of dark matter and primordial gas, possessing a gravitational mass that dwarfs Laniakea and the Shapley Supercluster combined. We can never see them because their light will never have enough time to reach us across the expanding void. Yet, because gravity is a fundamental distortion of space-time itself, the geometric tether between our region of space and theirs was never entirely severed. The 1.3 million mile-per-hour free-fall of our galaxy is the phantom pain of an amputated universe. We are being hauled relentlessly toward the heavy, missing pieces of our own origin. This realization forces a grim, logistical question. What happens to us? What awaits the Milky Way at the end of this cosmic migration? If we are hurtling at millions of miles per hour toward a wall of unimaginable mass, whether it is the Shapley Supercluster or the invisible titans beyond the horizon, will we eventually collide? Will our galaxy plunge into a hyperdense war zone of tearing gas and colliding supermassive black holes? To calculate our fate, we must introduce the ultimate, cold-blooded antagonist of the cosmos, dark energy. In 1998, two independent teams of astrophysicists observing distant supernova made a discovery that paralyzed the scientific community. They found that the expansion of the universe was not slowing down under the collective gravitational weight of its own mass, as everyone had rationally assumed. It was accelerating. Some mysterious, repulsive force, a property inherent to the vacuum of space itself, was actively pushing galaxies apart. We call this force dark energy, and it makes up roughly 68% of the total energy density of the universe. To quantify this, astrophysicists use the cosmological constant, denoted by the Greek letter lambda. It describes the energy density of empty space. On a local scale, this density is infinitesimally small, roughly 10 to the power of minus 9 joules per cubic meter. Inside our solar system, or even within the gravitational grip of the Milky Way, the attractive force of matter completely overpowers it. But dark energy is a property of volume. The more space there is, the more dark energy there is. Over the yawning, multi-million light-year chasms between superstars, this microscopic negative pressure accumulates into an unstoppable, repelling tide. Dark energy changes the entire math of our freefall. While the Great Attractor, Laniakea, and the phantom masses beyond are reeling us in through the immense power of gravity. Dark energy is actively creating more physical space between us and our destination. The metric of space-time is stretching from the inside out. It is a cosmic race between peculiar velocity and metric expansion. You can visualize it as running on a massive, motorized treadmill. You are sprinting forward at a terrifying speed, your muscles burning, your momentum carrying you toward the front of the machine. But the treadmill belt is not just moving backward. It is physically stretching, becoming longer and longer with every step you take. Right now, the Milky Way is traveling at over 2 million kilometers per hour toward the Centaurus Vela region. By any human standard, this is an apocalyptic velocity, but on a cosmological scale, against the sheer, overwhelming power of dark energy, it is mathematically pathetic. The proper distance between the Milky Way and the Shapley Supercluster is approximately 650 million light-years, because dark energy is accelerating the expansion of the space between us. The Shapley Supercluster is technically receding from us faster than we are falling toward it. We are plunging toward a destination we can never reach. This introduces an existential consequence far more disturbing than a cosmic collision. If dark energy continues to accelerate, which all current cosmological models strongly predict, it will eventually overpower all large-scale gravitational bounds. The universe will enter a phase of runaway expansion. The physical space between galaxy clusters will stretch so violently that light itself will no longer be able to cross the expanding gulfs. This creates a moving, suffocating boundary known as the cosmological event horizon. Right now, we can see the galaxies in the Norma cluster. We can measure the immense mass of Shapley. We can detect the faint, ghostly pull of the dark flow from the edges of our reality. But as the cosmic clock ticks forward, dark energy will physically drag these structures away from us faster than the speed of light. One by one, the galaxies pulling us will slip past the cosmological event horizon. Their light will redshift into absolute blackness. They will simply blink out of existence from our perspective, forever inaccessible, sealed away behind an impenetrable wall of expanding space. First, the anomalies outside our observable bubble will be pushed infinitely far away. Their gravitational tether will snap. The dark flow will slowly decelerate and cease. Then, the Shapley Supercluster will fade into the black, severing its hold on Lania. Even the Great Attractor, the massive dark matter valley we are sliding into, will eventually be torn away by the sheer expansive force of the vacuum. We will not crash, we will be abandoned. The synchronized, terrifying migration of millions of galaxies that we observe today is a temporary state. We are living in a fleeting window of cosmic history where the universe is still dense enough, and the light is still young enough for us to perceive the grand architecture of our prison. We are blindfolded passengers locked inside a moving vehicle, and just as we have finally managed to map the shape of the engine and the direction of the road is disintegrating into nothingness beneath our tires. Eventually, the Milky Way, having merged with the Andromeda Galaxy into a single, massive, elliptical structure, will be left entirely alone. The night sky will be stripped of all other galaxies. Our descendants, billions of years from now, will look out into the void with the most powerful telescopes imaginable, and they will see absolutely nothing. No great attractor, no cosmic microwave background, no evidence that the universe is expanding or that anything else ever existed beyond their own localized island of dying stars. They will not know they are falling. They will not know they were once part of a grand, terrifying river of mass that flowed across billions of light-years. They will believe the universe is static, empty, and eternally dark. The absolute truth of our motion, the very mystery that consumes us today, will be completely erased from the physical record of reality. The universe is not just hiding the destination from us. It is actively dismantling the evidence of the journey. The universe is not just hiding the destination from us. It is actively dismantling the evidence of the journey. We are living in a privileged, transient epoch of cosmic time. We exist in a fleeting twilight, a brief cosmological window where the universe is still young enough, and the light from distant superclusters is still reaching us, allowing us to perceive the grand, terrifying architecture of our own freefall. We are the first, and perhaps the last, consciousness to map the invisible currents of the dark. To understand our true position in the cosmos is to accept a profound and irreversible isolation. We have built monuments of glass and steel upon frozen mountain peaks. We have launched exquisite, cryogenic instruments into the freezing vacuum of orbit. We have mathematically reconstructed the velocity of millions of galaxies, moving in perfect, horrifying synchronization. We have named our ghosts. We have measured the exact weight of the dark. And yet, all of this magnificent intellectual architecture changes absolutely nothing about our trajectory. We remain utterly powerless against the mechanics of the void. The sheer scale of the forces at play, the tens of quadrillions of solar masses, the microscopic, relentless push of dark energy, the phantom tug from structures permanently exiled beyond the edge of reality renders human existence mathematically irrelevant. We are not the protagonists of this universe. We are a momentary biological anomaly clinging to a single, unremarkable grain of dust, caught in a cosmic watershed that is slowly being pulled apart by the very fabric of space itself. Our human timeline, with all its wars, its empires, its discoveries, and its tragedies, is entirely encompassed by a fraction of a millimeter on this million-mile-per-hour journey. We are born in motion, we live in motion, and we will die in motion. For now, the river flows, the Milky Way, carrying our sun, our planet, and the fragile memory of everything we have ever known, continues its silent, relentless plunge across the cosmic map. We are falling at 1.3 million miles per hour toward a dark matter valley we will never reach, dragged by the gravitational ghosts of a shattered, pre-inflationary universe, constantly fleeing a desolate void that pushes us from behind. Eventually, the accelerating expansion of the cosmos will outpace the ancient pull of gravity. The dark flow will fade into nothingness. The Great Attractor and the Shapley Supercluster will slip silently past the cosmological event horizon, permanently severing their invisible tethers to our galaxy. The night sky will empty out, the neighboring galaxies will vanish into the black, and our observable universe will become a cold, static, and deeply lonely island. The evidence of our great migration will be permanently erased, but tonight, the vector remains unbroken. If you look up at the sky, past the thin blue atmosphere, past the friction and the comforting, localized illusion of absolute stillness, remember the sheer violence of our velocity. You are hurtling through the freezing dark, locked into an unforgiving mathematical inevitability, plunging toward an invisible titan hidden behind the dust of our own home. We are falling into the deep, and there is nothing out there waiting to catch us.